So in this video, we are going to investigate the sum of the angles in a polygon. So let's go through this together. Let's start off with part one. Question number one asks how many degrees are in the sum of the angles of a triangle? You might have been thinking 180 degrees. Please also put that on your paper as well. If you know the answer to question number one, which we do, it's 180 degrees, you can find the sum of the interior angles in any polygon by simply dividing the polygon into triangles. Find the number of degrees in the sum of the interior angles of quadrilateral ABCD. Notice that a diagonal has been drawn, dividing the quadrilateral into two triangles. Measure of angle 1 plus measure of angle 2 plus measure of angle 3 should equal 180 degrees. Those are the three angles of triangle BAD. Measure of angle 4 plus measure of angle 5 plus measure of angle 6 equals 180 degrees. 4, 5, and 6 are the angles in triangle BCD. Okay, so measure of angle 1 plus measure of angle 2 plus measure of angle 3 plus measure of angle 4 plus measure of angle 5 plus measure of angle 6. Well, we said that angle 1 plus angle 2 plus angle 3 is 180 degrees. And angle 4 plus angle 5 plus angle 6 is also 180 degrees. So 180 plus 180 makes 360 degrees. So the sum of the interior angles of a quadrilateral is 360 degrees. So anytime you see any four-sided shape, any quadrilateral, like here, A, B, C, D, is a four-sided shape. 1, 2, 3, 4 sides. It's a quadrilateral. So anytime we have a quadrilateral, all four of its angles should add up to 360 degrees. So angle A plus angle B plus angle C plus angle D of this quadrilateral should add up to 360 degrees in total. Okay, now let's find the number of degrees in the sum of the interior angles of Pentagon A, B, C, D, E. So a hint here is from one vertex to draw all possible diagonals. So I'll pick vertex E. You can pick any vertex that you want. And I'll draw in diagonal EC and diagonal EB. I can't draw diagonal EA because that would just be a side of the pentagon. So I'm going to undo that. And I can't draw in diagonal ED. Oops. Because once again, that would just be a side of the pentagon. It wouldn't be a diagonal. So to form a diagonal, I can connect any of the vertex points with another vertex point that's not right next to it. So E and D, since they're right next to each other, that would be a side. E and A, since they're right next to each other, that would be a side, now the diagonal. But now that I picked a vertex and I drew in all the diagonals that I could from that vertex, we can see how many triangles are formed. There are 3 triangles. Triangle 1, triangle 2, and triangle 3. The sum of the angles in each triangle is 180 degrees. So the sum of the interior angles of a pentagon is, since there are 3 triangles making up this pentagon, and each triangle has an angle sum of 180 degrees, all we need to do is do 180 degrees plus 180 degrees plus 180 degrees for each of the 3 triangles. Or we can do 180 degrees times 3, and that will make our calculations a little bit simpler. So 180 times 3 is 540 degrees. So anytime we have a pentagon, we now know that the sum of the interior angles is 540 degrees. Okay, now we have a hexagon, a 6-sided shape. We started with quadrilateral, that was 4-sided. Then in number 3, we did pentagon, that was 5-sided. And now we're going to talk about a hexagon, which is 6-sided. So once again, it says from one vertex, draw all possible diagonals. So take a pause from this video, pick a vertex, and draw in all the possible diagonals. I'm going to pick vertex C this time. It doesn't matter which vertex you pick. And I'm going to connect from C to A, from C to F, and from C to E. I can't connect from C to B because if I do, that just gives me a side of the hexagon, not a diagonal. Same thing with D to E. If I connect with C to D, if I connect there, once again, I just have a side of the hexagon. Remember, a diagonal is formed by connecting any 2 vertex points that are not right next to each other. If the 2 vertices that you're picking are next to each other, it's going to be a side of the shape. So no matter which vertex you started from, when you drew all your possible diagonals from that vertex, you should see the same number of triangles as we're seeing here on my screen. There are 4 triangles formed. 1, 2, 3, 4, 4 different triangles. The sum of the angles in each triangle is 180 degrees. So the sum of the interior angles of a hexagon is 180 plus 180 plus 180 plus 180, or 180 times 4, because there are 4 triangles here. 180 times 4 is 720 degrees. So anytime we have a hexagon, all of the angles of a hexagon, all 6 of its interior angles, will always add up to 720 degrees. So we're starting to see a pattern develop between the sum of the angles in a polygon and the number of triangles that make up the polygon. So let's complete the following chart to find the pattern. So we're going to have to scroll up and look at what we did in order to complete this chart. So quadrilateral was the 4-sided shape, and we were able to divide that into 2 triangles. 4-sided shape, 2 triangles. And the sum of the interior angles of a quadrilateral was 180 plus 180, making 360 degrees. Okay, let's put in the pentagon. So the pentagon we did over here in number 3. So the pentagon, the 5-sided shape here, was able to be divided into 3 triangles, and the sum of the interior angles was 540. So there were 5 sides in a pentagon. It could be divided into 3 triangles. Oops. And the sum was 540 degrees. Okay, hexagon, that's the last one that we did on the previous page. A hexagon is a 1, 2, 3, 4, 5, 6-sided shape. We were able to break it into 4 triangles, and the total interior angle sum of a hexagon was 720 degrees. We can complete the rest of the chart, even though we didn't specifically look at 7-sided shapes, heptagons. 8-sided shapes, octagons, 9-sided shapes, nonagons, 10-sided shapes, decagons, or 12-sided shaped dodecagons. Let's follow the pattern and complete the rest of the chart. So that's a 7-sided shape, 8-sided, 9, 10, 12. A dodecagon has 12 sides. So the number of triangles we can break it down to. So that's 1, 2, 3, 4, 5, 6, just following the pattern. 7, 8, 12-sided, so 10. There's a jump there. It goes from 10 to 12, so I made the jump here from 8 to 10. Some of the interior angles. So since a triangle has 180 degrees, all we have to do is multiply the number of triangles each shape is divided into by 180 degrees. So 5 times 180 degrees is 900. 6 times 180 degrees is 1080. 7 times 180 is 1260. 8 times 180 is 1440. And 10 times 180 is 1880. So now let's generalize this information for a polygon with any number of sides, because we don't want to have to remember how many, what the sum of the angles are for every single polygon. So let's make a general formula. So that way, if we know how many sides the polygon has, we can easily find what the sum of the angles of that polygon is. So let's say it has an n number of sides. I don't know what number of sides it is. Let's say it's n. It could represent any number of sides. In order to find the number of triangles, we took the number of sides and we subtracted 2. 3 minus 2 gave us 1. 4 minus 2 gave us 2. Jump down a bit. 9 minus 2 gave us 7. 10 minus 2 gave us 8. 12 minus 2 gave us 10. So we can represent that as n minus 2. And then to find the total sum of the interior angles of the polygons, we took the number of triangles and multiplied by 180, since triangles do have angles that add to 180 degrees. So if the number of triangles is represented as n minus 2, the way that we find the sum of the angles from that is taking n minus 2, which is the number of triangles, and multiplying by 180 degrees, since every triangle has angles that add to 180 degrees. And here is our formula. I'll put it here. Oops. Let me undo that. So here's our formula. To find the sum of the interior angles of any polygon, all we need to do is do n minus 2 times 180. So once again, n represents the number of sides that the polygon has. So if the polygon was a 9-sided polygon, I would plug 9 in for n. 9 minus 2 would give us the number of triangles that 9-sided polygon can be divided into. And then we'd be multiplying by 180, because triangles add to 180 their angles, to find out what the total sum of the interior angles should be. So this works for any polygon that you want to find what all their angles add up to. Take the number of sides, subtract it by 2, and then multiply that by 180. Let's continue our investigation by looking at individual angles in some specific polygons. So take a second and describe what is required for a polygon to be described as regular. A regular polygon is a polygon that has all congruent sides and all congruent angles. So take a second and write that down for number 1 on your worksheet. What is the sum of the measures of the interior angles of any polygon? Well, we just talked about that before and we came up with it. Our formula for finding the sum of the interior angles of any polygon would be n minus 2 times 180, where n is the number of sides that the polygon has. What is the measure of one angle of a regular polygon? Well, if our formula n minus 2 times 180 gives us the sum of all of the angles, and the polygon is regular, meaning that all the angles are equal, all we have to do is divide by the number of angles that there are to find out what each angle should measure. So I'm just taking our formula from before and dividing it by n, by the number of sides, which is also the number of angles, to get just one angle in that regular polygon. What is the measure of one angle of a non-regular pentagon? Oh, I didn't realize for 2 and 3 and also 4, they want us to do this for a pentagon. So on your paper, plug in 5 for n and find out, when you do 5 minus 2 times 180, what do you get? That's the sum of the measures of the interior angle of any pentagon. For number 3, plug in 5 for n again, the number of sides a pentagon has, and plug in 5 for n at the bottom. So that would be 5 minus 2 times 180 over 5. And what you get from that would be the measurement of one angle of that pentagon. What is the measure of one angle of a non-regular pentagon? Well, the angles are not all equal, so I wouldn't really be able to figure that out unless I have some more information about the angles in that pentagon. Describe how to find the measure of each angle of a regular polygon. Well, all you have to do is take the formula for the sum of all the angles and divide it by the number of sides, which is also the number of angles, to get just one angle in that regular polygon. And that's it. Remember, in order to use this formula over here to find the measurement of one angle, you do need to have a regular polygon, because if you don't have a regular polygon, we don't know that all the angles are the same. So I don't know that just dividing by the number of angles that there are will give me the measurement that I'm looking for unless all the angles are the same. So just keep in mind this formula over here is specifically for regular polygons, but the original formula, n minus 2 times 180, will give you the sum of the angles of any polygon regardless of whether it is regular or not. So take a second and fill in the chart below as part of your homework. For each of the regular polygons here, find the sum of the interior angles. So use the formula n minus 2 times 180. And for the measure of each interior angle, since it's a regular polygon, since we specify regular polygon, you can plug into our second formula for finding just one angle in the regular polygon, n minus 2 times 180 over n. And if you need more space to do your work, you can use a separate piece of paper. But all you need to do is put your answers in the boxes. And the box over here that says for an n-gon, that means in general for a polygon, a regular polygon of any side, number of sides. So since that just means the general formula, that's the formulas that we talked about in this video. the formula for sum of the interior angles of a polygon, and the formula for the measure of each interior angle of a regular polygon.